Aldo from Zero to Mastery here. In today's tutorial, we're diving into C# value types. Now this isn't just any tutorial, it's part of Claudio Bernasconi's complete C# and .NET Bootcamp course available on Zero to Mastery. So whether you're just starting out with C# or looking to sharpen your skills, click the link in the top right hand corner or check out the description below for the full course. Alright, that's it from me. Let me hand it over to Claudio. Enjoy!
C# value types. There are two categories of C# data types. There are value types and there are reference types. A variable of a value type contains the value itself. In contrast, the variable of a reference type contains the reference to an instance of the type, hence the name reference type. In this lesson, we're going to look at value types. There are 4 categories of value types built into .NET and available when developing applications in C#. Integral numeric types, floating point numbers, bool, and char. Let's go through those 4 categories one by one. C# supports 9 integral number types with different sizes and value ranges. All of them are stored in a binary format. In more than 15 years of .NET development, I mostly use the integer or short int, long, and char types. Those are the most common types that I suggest learning in depth. For example, I know that an int has a range of a little more than 4 billion and uses 32-bit of memory. If I need to store larger numbers, I use long, which allows me to store a 64-bit number with a value range I cannot memorize. The other types are situational and can be used to save memory when you know that you have to deal with a lot of data and know that you won't exceed the value range of a smaller integral type. C# supports 2 floating point types, float and double. The float type is a 32-bit type and the double type is a 64-bit type. This difference makes the double type more precise. In other programming languages, there are similar data types often called single and double precision floating point types. In C#, a float has single precision and a double has, as the name suggests, double precision. As we can see from this table, floating point types have a much bigger value range than integral data types. While integer data types are stored in a binary format, floating point numbers have a more complex representation in memory. Scientists have developed a standard for representing a floating point number in digital systems to allow for bigger numbers. The short explanation is that the sign, positive or negative, the exponent, and a fraction are stored. If you're curious, you can read more about it in the IEEE 754 standard. A critical aspect of floating point types and how they are stored is that they cannot represent every value of the value range. The result of a floating point operation is rounded to the nearest representable value. It makes floating point types valuable in scientific scenarios, but I wouldn't store bookkeeping data or salary information in a floating point type. But what if I want to store a decimal number? What if I need a good precision and a big enough value range? In this case, the decimal type is what we need. The decimal type is another floating point number, but contrary to float and double, decimal can be used for financial and monetary calculations. The type provides a 28-digit precision, which should be enough for most typical applications. Decimal types are stored in a decimal format. Numbers such as 0.1 can accurately be represented in memory, and calculations should not be rounded because all values in the value range can be represented. The biggest downside of decimals compared to integrals and other floating point numbers is the memory consumption. Decimal uses 128-bit, which is double the size of a long or double and 4 times the size of an int. The bool type represents one of 2 Boolean states. A bool is either true or false. Those 2 states can be represented using a single bit. However, in a C# application, a bool takes 1 byte in memory due to a technical restriction and optimization of the .NET platform. It's still one of the types with the smallest memory footprint. The char type is classified as an integral type. However, compared to the integral number types we learned at the beginning of this lesson, the char type has 2 differences. While you can implicitly convert numbers between the different integral number types, you cannot implicitly convert the char type to another integral number type. And the char type is always unsigned, which means that it cannot store negative numbers. The char type uses 16-bit memory and ranges from 0 to 65,535, which means that the char type has the exact size to store a Unicode character. We looked at 12 value types in this lesson. For me, the most important and most used value types are int, long, bool, float, double, and char. It's not necessary to memorize information that you don't regularly use. If you remember those 6 types and know which type to use in which scenario, you have already mastered 90% of them. If I find myself in a use case where I need another type, I open the documentation and look it up.
And that's a wrap on C# value types. A huge thanks to Claudio for this great tutorial. If you found this snippet helpful, just imagine what you can learn in his complete C# and .NET Bootcamp course. You probably already know where to find that. Linked in the top right hand corner and in the description down below. Also, don't forget to like, subscribe, and hit that notification bell so you never miss out on future tutorials from Claudio and other expert Zero to Mastery instructors. Alright, that's it from me. Keep on learning, and I'll catch you in the next video.